go according to timetable. So we will try. We are trying that our PP practical and theory will get over by 15 only. Before than that, if possible, because in this chapter of drug stability, very few things are remaining, and we are already started with that. That is a basic mechanisms of degradation. And last portion is with accelerated stability studies, ICH guideline that we already covered during the practical actually. But still we will superficially complete it with theory also. And last topic that will remain, it will be micromeritics. We have covered the practicals also based on that. Micromeritics is easy to understand and very fastly we can go. So you will get enough time for the preparation, because considering 24th is the examination date. Okay. So so you can tell other teachers what is the status of other subjects, how much portion left, Dipesh? Hello, hello. What is the status, completion status of other teachers on other subjects? Dipesh, are you there? Hello, am I audible to all of you? Yeah, anybody can tell me how much portion is remaining with other subjects? किती युनिट बाकी? हाँ. हम्म. ओके. आणि आणखीन बाकी सब्जेक्ट? ओके, किती बाकी आहे त्यांचा? अच्छा. ओके ओके. म्हणजे मला हे म्हणायचं होतं की जर का त्यांचे लेक्चर्स आपल्याला मिळाले तर मग एक्स्ट्रा लेक्चर घेण्याची आवश्यकता पडणार नाही, त्या रेग्युलर शेड्यूलमध्येच आपलं कम्प्लिशन होईल म्हणून मी विचारत आहे. So if you can tell any time that if any lecture will be free within schedule lecture, जो टाइम टेबल आहे त्याच्यामध्ये काही फ्री असेल तर मला लगेच थोडं 5 मिनिटं अगोदर सांगा, तर त्यामध्येच मी कव्हर करू शकतो. म्हणजे मग तुम्हाला त्या दिवसाचा एक्स्ट्रा लेक्चर करण्याची आवश्यकता नाही किंवा राहणार नाही, किंवा मग एक्स्ट्रा लेक्चर पण घेतला तर मग 15च्या अगोदर आपण पोर्शन कंप्लीट करू शकू. Whenever you will get a free lecture, you can tell me. So within 5 minutes, I can join and conduct my lecture. So that care you have to take so that you can get more and more time for your exam preparation. Okay, keep in mind. So now to be continued with our portion, that is drug stability. So is PDF visible to you? Hello. Yeah. So what we did, we have done with the yeah, we have done with the dielectric constant, factors affecting drug stability. In that we have covered the dielectric constant. Now we are going to cover the catalysis. As we know, catalytic agent are not involved with the chemical reaction, but they can accelerate or decelerate the action or occurrence of chemical reaction. The rate of a reaction is also influenced by the presence of catalyst. A catalyst is a substance that either increase or decrease the rate of reaction but itself remain unchanged chemically without actual taking part catalyst work. The catalyst also makes the reaction faster. The catalyst that reduces the rate of reaction is called negative catalyst. There are following types of catalysis: specific acid-base catalysis, general acid-base catalysis. In case of specific acid-base catalysis, we can say specific, as we know that if we take the buffer or some other solution and we add the acid, and due to that the rate of chemical reaction will get increased, so that we can say the reaction rate get elevated by acid component. So that specifically either acid or base will accelerate or decelerate the chemical reaction. That you have to understand. If drug solution is buffer, the decomposition may not take place by change in concentration of acid or base, because buffer is there. If small quantity of acid or base will add, it will not it will show the resistance to change in pH, so that the reaction may be considered to be catalyzed by H positive or OH negative ions, because we will add either acid or base in that. When the rate equation involving concentration of H positive or OH negative, the reaction is said to be specific acid base catalyzed. So name itself indicating that a specific either acid or basic component will involve, and that will be responsible for the increment or decrease in rate of reaction. The effect of H positive or OH negative concentration on specific acid base catalyzed reaction can be expressed by the following equation. Observe a rate constant is given by K observe, that is K0 plus K1 H positive plus K2 OH negative. At low pH, hydrogen ion concentration is greater than K0 and K2 OH. In case of low pH, H positive ion concentration will be greater than the other concentration. The observed, so in this case then, the observed reaction rate constant will change into this equation. K observation is equal to K1 concentration of H positive. One component is there, square bracket is there, exponent or power is 1. So obviously it would be first order kinetic. Anybody can guess if they are now understood the earlier lectures. At higher pH, means at alkaline pH, the OH ion concentration is greater than K0 and K1 H positive. The observed reaction rate will be K observed K2 OH negative. So this reaction is called as base catalyze. Means specifically either H positive or OH negative will influence the rate of chemical reaction. So that it has been told. At intermediate pH, the concentration of H positive and OH negative are low, or if the product of KH positive, K1H positive and K2H positive are small in value, the observed reaction rate constant becomes K observation that is equal to K0. This is solvent catalyze because there is no any other component or reactant that would get involved. So some other component apart from the reactant or the component is involving and influencing the chemical reaction so that the reaction rate equation goes or changes. This is all about the specific acid or base. Now general acid base catalysis. A reaction in which undissociated acid or base produce catalytic effect on the rate of reaction. Very important or differentiable. It is undissociated. Undissociated means ions should not be there. Molecule should be there only. Undissociated acid or base produce catalytic effect means molecular acid or molecular base will only govern the acid base reaction. Okay, general acid base catalyzed reaction. Example is pharmaceutical formulation. Uses mute yourself, mute yourself. Whose voice is coming? Mute yourself. You are not attending the lecture. Who is this? दीपेश हे कोणाचा आवाज होता हा कोण हु इज दॅट स्टुडंट they are not attending the lectures and they might have given the mobile phones to children's कोण मी मेन याच्यावर जात नाही मेन विंडोवर जात नाही बिकॉज इट मे बी कनेक्शन may be loose so that anybody can tell who is that person who is not muting themselves. कोण आहे बाकी लोकांनी सांगा कोणीतरी तुमचे मित्र आहेत मला माहिती आहे परंतु त्यांना सांगावं तर लागेल ना म्यूट युअरसेल्फ. Okay. Now, examples of that. Pharmaceutical formulations are uses buffers for maintaining the pH of the solution. One or more component of the buffer catalyze the rate of reaction. If the catalytic component is acidic, the reaction is said to be general acid catalyzed. If the catalytic component is basic, the reaction is said to be general base catalyzed. Specifically, H positive and OH negative are not involving. Instead of that, components of buffer are is influencing the rate of chemical reaction. Influencing means in this case of buffer, it may decrease also. So that is very important because the components of buffer, what they will do, obviously the components of buffer will retard the rate of chemical reaction. Okay, so it is somewhat opposite to earlier one, but either they can resist the acidity or they can resist the basicity. So that it has been told that general acid catalyze or base catalyze. So this important point you have to keep in mind. Common buffer salts that have a catalytic effect are acetate, phosphate, borate buffers. The evaluation of general acid or base catalysis is done by obtaining the degradation rate of a drug in a series of buffer having the same pH, but they should be prepared with increasing concentration of buffer species. Means different concentrations of buffer and different containing different components we will prepare, and then we will you can say study or evaluate the general acid-base catalyzing reaction. If rate of degradation is found to vary with concentration of the buffer components, the reaction is said to be general acid base catalyzed. So very clear. I guess the difference between the general acid base catalyzed and a specific acid base catalyzed. In general, acid base catalyzed, most of the talk will be with the buffer. Most of the changes will be with the buffer. And then if the changes are influencing, then we can say it is a general acid base catalyzed. And if and when we take the amount of acid or amount of base and it is changing the pH, then it is called as the specific acid base catalyzed reactions. Okay. Then next, drug stability means another point in that. So this is all about the factors which has been covered by us. So next point is the stabilization of medicinal agent against common reactions. Now common reactions already told: oxidation, reduction, carboxylation, polymerization, decarboxylation, isomerization, epimerization. All these are the mostly common reaction. And त्याच्यातही जास्त mostly म्हणजे it is hydrolysis, oxidation, photolysis. Okay. And it is now in this section what we are going to understand how we can prevent our drug formulation or our drug from occurrence of degradation by these ways or by these pathways. So that is the this is the point we will discuss over here. Stabilization of medicinal agent means actives, means drugs against common reactions. Loss of drug through a chemical reaction leads to reduction of potency of drug, which results in drug instability. So many times you have seen that there are so much potent drug, very much potent drug, and in that potent drug, what is potent drug? With less quantity also, they can have the capability to show the pharmacological activity. Potent means it may be very less, maybe 2 milligram, it may be 1 milligram, 0.25 milligram, it may be or in the microgram also. With very less quantity, the drug is having the capability to show the pharmacological activity. And less quantity means less molecule will be there. Okay. So the most common cause of instability or degradation of drugs are as follows: hydrolysis, oxidation, photolysis. Now one by one we will see. Hydrolysis. Hydrolysis always been associated with water. It if breaking of molecule is due to reaction with water, then it is called as hydrolysis. When the drug formulation or the drug will come in contact with water, and due to presence of water, the drug molecule got break. Okay, and not only break, it may form some other component than the original. Okay, it's called hydrolysis. Influence of water is there. It is a step in degradation of substance. Drugs like esters, amides, lactams undergo hydrolysis. Medicinal chemistry आहे का तुम्हाला? Do you have the medicinal chemistry in this is what you call semester? Do you have the medicinal chemistry? Do you have the beta lactam antibiotics to study? Do you have beta lactam antibiotic for the study in Medichem? Yes or no? आतापर्यंत शिकले असेल ना तुम्ही? पहिला मेडिसिनल केमिस्ट्री आहे का दुसरा आहे? इज इट फर्स्ट टाइम आहे का त्याच्यात? बीटा अँटीबायोटिक मध्ये बीटा लॅक्टम अँटीबायोटिकचा कधी उल्लेख झाला का? ओके, ठीक आहे. मग ते अँटीबायोटिक तुम्हाला पुढच्या सेमेस्टरला असेल कदाचित. तर दॅट इज कॉल्ड द लॅक्टम्स. मीन्स lactam ring will be there in that beta lactam antibiotic especially. Basically, these are the class of antibiotic that I want to tell. So drugs like esters, amides, lactams undergo hydrolysis. They are prone to get degraded. Hydrolysis reactions are governed by the following principles. Drugs with or amide functional group react with one molecule of water and undergoes hydrolysis. So ester and amide are susceptible for the degradation. Amide group have a slow decomposition rate than ester groups. So among those also, in between them also, ester is more susceptible for the degradation than the amide. Reaction between ionic drugs proceed faster than with the neutral molecules because hydrolysis is a solubility phenomena. When the drug will get solubilized in the solution or in the water as a solvent, then only individual molecule will appear, and that individual molecule when appear, then only it may get split up by the water molecule. Okay, especially. And then hydrolysis reactions are catalyzed by H positive and OH negative ions. OH negative ions catalyzes hydrolysis, especially 0 to 1000 times more actively involved than H positive ions. Means when we consider hydrolysis, more prominent OH negative ions are playing its important role in case of hydrolysis reaction. Examples of drug decomposing by the hydrolysis pathway: esters, aspirin, procaine, atropine, physostigmine, amides, chloramphenicol, barbiturates, dibucane, ergometrine. So these are the examples they have given. You don't have so much details about that. Just you have to keep the you have to give the examples. You have to give the these reactions that you have to tell. Okay. So here it has been shown how the split up is occurring onto the with the propyl ethionate, which is ester. Ethionate net is there, ethionate is there, that is itself a ester plus water giving acid and alcohol. So that more prominent is the alcohol, sorry, more prominent is the OH ion that is playing its important role. Hydrolysis of amide, R C double bond of NH, R dash plus H2O, it gives again carboxylic acid. Okay, then, so this is the mechanism. Many polyamide polymer such as nylon 66 hydrolyze in presence of strong acid, and this is called depolymerization. Here it has been mentioned that nylon 66, it is the polymer, it is a association of monomer, so it would in presence of it would get hydrolyzed in presence of strong acid. Okay, due to that the depolymerization means again the reformation of monomer will occur. So these are the good example they have given. You can mention it in the answer when the question comes. Okay, are you understanding the things? One by one we are taking. First we are taking the hydrolysis. Am I audible? Yeah. So in this section, mostly they have discussed the chemical and its kinetics only. Hydrolysis can be prevented by different approaches. In that, buffers are used to reduce the rate of hydrolysis and stabilize the drugs. Just now we have taken the general acid-base catalysis. Similar kind of examples can be quoted over here. Okay, so because buffers are playing the important role to retard the hydrolysis reaction. By adjusting the pH of a solution, stability and therapeutic activity of the drug are maintained. In most of the cases, optimum pH remains 3.5 to 5 because in this range, hydrolysis catalyzed by H positive and OH negative ions are almost equal. Okay, so this pH would be desirable to be maintained. The rate of hydrolysis can also be prevented by reducing exposure to water. So that we are doing uh, by keeping our tablet, capsule, or some other drugs away from the moisture. You might have seen that in bulk containers, bottle packing में. Okay, in that moisture, you can see what is that component, moisture adsorbent ते असतं, that is absorbing the moisture from the tablet or in the container. That is called what is the name of that? I am forgetting. Okay, later I will let you know. Yes, but what is the name of that? काय म्हणतात त्याला? नाही नाही ते तर एक नाही तो एक सबस्टन्स झाला. पण त्या सबस्टन्सला इन जनरल काय म्हणतात? मॉइश्चर काहीतरी त्याचा एक वर्ड आहे पर्टिक्युलरली, की जे मॉइश्चर रिटायर्ड करतात, ऍब्सॉर्ब करतात, सक करतात. त्याला पर्टिक्युलर वर्ड आहे. So answer is correct and example is also correct. Silica which is placing in the pouch of that container. So let it be. When I will recall it, then I will let you know. The rate of hydrolysis can be prevented by reducing the exposure to water. The substance which are susceptible for the hydrolysis are packed in moisture resistant pack. It is absorbing the moisture into them. Complexation. Hydrolysis of cocaine and tetra etc. in aqueous solution can be inhibited by the addition of caffeine, which forms complex that decrease the rate of hydrolysis. So caffeine complex will be formed in that we have already seen the titration complexometric titration में हमने देखा है कि that we have done. And because what caffeine is doing over here, caffeine is not making availability of drug so that it would get exposed to water. So that the complexation process will responsible for the retardation of hydrolysis. Hydrolysis of some drugs such as penicillin can be prevented by covering it into a dry powder for converting into dry powder for reconstitution. Most of the times you might have seen that they are giving the antibiotic, especially penicillin or some other cephaloxime, cephalosporin. These antibiotics are very susceptible for hydrolysis. We cannot keep these drugs in contact for a longer duration of time, because if they come in contact with water, they start to degrade. That what we are doing as a formulator, although we are manufacturing the suspension, it deep freezing or freeze drying, and due to that, what is happening? All the water get loses, or solvent evaporation technique also can be used. All the water get loses, and it would get converted into solid powder, and that powder we are we are supplying with the additional water for injection pouch or bottle. And what patient have to do? Patient have to make the suspension, that is called the reconstituted suspension. Reconstituted suspension. What to be done? Uh, in that, the supplied drug material, which is in the form of powder, to be open, and the supplied water for injection, which is supplied along with that. Everybody, hello, am I audible to all of you? Okay, see the attendance, it is almost 60, and what I am teaching, it is very difficult. Okay, so everybody must join the lecture, although it is in the afternoon, but should join the lecture. Very important things are is getting covered. Okay, now the next. So I am sharing my screen. Just let me know whether it is visible. 1 minute. Yeah. Is it visible now? Is it visible? PDF? Okay. So hydrolysis we have finished. Now comes the oxidation. Oxidation is a common pathway. In pharmaceutical dosage form, oxygen is mediated by the reaction with atmospheric oxygen, very important, so that you will see that if you can read the package onto the strip packaging or blister packaging, you will see what film coating is doing. Film coating is preventing the exposure of the product to the atmospheric oxygen. Very, very important thing to be done. And almost all the formulations are film coated, involving the elimination of a electropositive atom, radical or electron, or the addition of electronegative group. So this is the basic mechanism of the oxidation. Auto-oxidation is the reaction of uh, compounds Yes, am I audible now? Okay, what we can do? We can stop over here. 10 minutes remaining. So later we can take that in the next lecture. Is it okay? ओके ठीक आहे. मग आपण तो टाइम टेबल जो मिळालेला आहे तो आपण फॉलो करूया अप टू 15. I will try my best. Before that only we can complete our syllabus. And because very less things are remaining and simple things are also remaining, so that I kept micromeritics in the last, because micromeritics is simplest among all the chapters. These are all difficult chapters: drug stability, course dispersion. These are all difficult chapters. So micromeritics is very comparatively simple chapter. It is with respect to it is all about the sizes only, nothing more than that. Okay. So with this I am ending the lecture. We will meet in the yes. Earlier yesterday also I told, but I have forgotten. Sorry for that. Today I will do that. ठीक है? Okay. Well.